Good afternoon, everyone. Hope you had lunch and full. So yeah, let's start with the next one under Web Tools and Complementary Technologies track. So this is about automated AI testing with Postman. And please welcome Michelle from Master Builders Association of New South Wales.
Hi, everyone. Welcome to the session on creating automated AI tests in Postman. So this session is not just for developers, it's for BAs, QAs, and technical support, subject matter experts, and project managers. I'm excited to show you the new testing methodologies we've been working on. Our project is the Building Information Gateway. It's a digital library for reference materials for the building and construction industry in Australia. We publish Australian standards, building codes, best practice guides, legislation, and more. Our documents range from 1 page up to 1,000 pages, and they can be very complex to search with tables, diagrams, symbols, images, and captions. But even more complicated are the multiple document versions, amendments, supplements, and compilations. And with documents for different dates, different trades, in different locations, and for different building projects, well, as I said, complex. BIG uses a Solr search engine to index these documents as well as the library catalogue metadata, because users need to refer to these documents to answer their questions. But we want an easier way for our users to find the answers, so we're looking to AI as a solution. Technocrat are our developers on the BIG project, and this AI is using their CarbonAI product. The objective is a chat-based AI that allows our users to ask detailed and specific questions about any topic in our library. For Phase 1, the concierge will help users by showing them the full context of their answers within the original source material. So why do we test AI? Doesn't AI know everything? Well, as I mentioned, our library is complex and the AIs are still new and experimental. So we've developed some new testing methodologies to do 4 main things. First, to confirm our understanding of document content. For example, some documents may have conflicting or alternate information. Second, we want to confirm how our metadata is applied and how that affects the AI responses, for instance, our document priorities. Third, analyse and compare the AI's confidence in an answer in a specific document, and that's its relevance score. And last, fully understand what the AI's responses include and ensure that they're consistent from session to session. So how do we test? We already used Postman extensively on BIG, so it was an obvious choice to use for AI testing. Postman is actually a platform for building, testing and monitoring APIs, but we found it indispensable for our project in many ways. So here's what we did to test our AI. We recorded an AI session in Chrome using a Postman interceptor extension. We saved the request to a collection in Postman, and we analysed the JSON responses to those requests. We prepared a test suite as a CSV file, and then added variables and test scripts in Postman. Then we ran the test in Postman and then later in Newman on the command line. Let's take a look at this process. The first thing is to record an AI session in Chrome with a Postman interceptor extension. So we'll start Interceptor, then log in to start a chat session, ask a question, view the answers from the AI, and then stop Interceptor when we have what we need. With the Postman application running, go to Chrome and open the Interceptor extension. Click Start Capture, and this will record all the requests and responses directly to Postman until you stop the capture. The first request is to load the AI page as a user using basic auth, and this will be captured as a GET request. The next request will be our question. In this example, we asked, what is the date of the most current version of the NCC housing provisions? And since we submitted it, it will be captured as a post request. For this testing, we're suppressing the chat responses and just looking at the document sources. So we can see in this session that we have the file name, the reference page, the priority, and the relevance score listed. Now inside the Postman application, we have the capture from Interceptor, and we need to save both the GET request for the page load and the post request with our query as a Postman collection so we can edit it, run it, and automate it. In this example, we can see the post request response in Postman, and there's a bit to go through here, so we'll break it down and look closer. This is the body of the post request in Postman. And we can see the format of the question that was sent to the AI. And moving down, we can see the response that was recorded from the AI with a lot of information. We have the success result, the documents returned, their file names, file type, page numbers, chapter and subsection, relevant score, the priority score, highlight text, and more. But we'll only care about a few of these things for our tests. And first, we need to save the requests as a Postman collection. So we'll save them as a collection called AI tests with our request load AI page and ask question. The next thing is to analyse that AI response. We'll need to look at the JSON to see what's available, what's important, what's not important, what makes sense for us to test, and in the end, what should we test, because too much can be too much. In our response, we got back an array of documents that answer the question. We determined that the information that was useful for us for testing was the file name, the page number, the relevant score, and the priority score. For the other information, we can add it later or ignore it if it's not useful. So next we'll need to prepare our test based on this useful information. For the BIG AI, we constructed real-world test questions. For each test question, we determined the page number of the expected answer from the AI. Since the AI results are sorted by relevance score, we cared about that. And since the priority score is used in the calculation of relevance and is part of the integration of our business logic into the AI, it's also important to us. Then we thought about what else we could add to the tests. So in preparing a spreadsheet of tests, we needed a query, that is the question. We needed a file name from our library catalogue. We needed the first correct page number in that document that answers that question, and the priority scores from our library metadata. And then we added an explanation note, the reason to display all testers to understand the purpose of the test. And after running the AI test once, we collected each relevant score and added those to the test suite as well. And as we added new documents to the AI, we added new tests. So from all of this information, we prepared a detailed test suite which we saved as CSV for Postman to use. This example has 8 tests. So let's look back at Postman. Firstly, we need to add variables for our test to run. We set up environment variables for when we switch to different environments like dev, staging and prod. We would also set up basic auth or username password variables to access the page either as environment or global variables. And lastly, we have the Postman iteration variables which are automatically populated from the CSV file. So in Postman, we replace the request URL with URL in double curly braces, and that sets it up as an environment variable. Same for password. Next, we replace basic auth password with the password variable. And since the username is the same for different environments, we'll add username as a global variable. Lastly, we replace the question text with a query variable, also in double curly braces. And this is the iteration variable, which will come from the CSV at runtime. Next step is writing test scripts in Postman. There are 2 types of scripts. We have pre-request scripts for setting up default test values and controlling test flow. And then we have post-response scripts which run after the response is received. And these are used to test performance, validation, expected results, and we also use it to log to console so we can see what's happening. We write our tests in Postman in JavaScript. Postman uses chai as its assertion library. Chai provides expect, should, assert styles for assertions, and we can check anything in the response, status codes, headers, data, etc. The aim is to handle passes or fails based on preconfined conditions, and the one simple performance test here is for us to understand the response time, so it's PM test to start the test, and PM expect to check that the response time is under 10 seconds. To test the response body, we need to parse the JSON raw response text, so we do that with JSON parse. And then we can work through each document returned in the response and log the things we're testing. For each document, we log the file name, the page number, the relevant score, and the priority. We do this because the AI might have found a better answer to our question in other documents, and we might want to add or update our tests based on this progression of the AI and the growth of our library. When we run our test suite, the iteration variables are automatically populated at runtime with each row in the CSV file. Of course, we can access them in code to log or test our expectations. To access them manually, we would use PM iteration data. And we log the query in the notes so that we have that information to display to testers. And for the page numbers and priorities, we pass as integers to be able to compare them accurately. Now let's log all of our expected information to the console so we can see what we're testing. We have the query question, the note, the expected file name, the expected page number, priority score, and relevance score. Finally, we create our tests to compare the results. For each test, we first need to make sure our expected document is actually in the results, otherwise that's a fail. We search by expected file name to get our match document, and then we want to check our page number is in that result for that match document. If it isn't there, we'll need to add a failed message to test result. Same for a priority score. If it doesn't match, something's wrong. So to pass each test, we expect that the test result string will be empty. That's no errors for that iteration. In the case of any issues running a test, we want to log those results to the console so we can see them. But we also want to fail the test with PM expect fail, so we have a summary of test results at the end of that run. When writing tests in Postman, we want to start small and ramp up. We can just click the send button in Postman to send that one request anytime, and for that it's convenient to use a pre-request script to set up default variables for testing our code. And then when the code's working, we can run it as a collection in Postman. When we run it as a Postman collection, we need to select a CSV file. We could try one with just one test first, and once we're happy with it, we can load our full test suite to run all the queries in order with a delay if necessary. The responses can be saved in Postman to view directly, in addition to the output in the console. For this session, we're interested in automating our tests, and to do that, we run the tests in Newman on the command line. And to do that, we need to export some files from Postman. First off, we export the collection itself as a JSON file called AI test Postman collection. We also export the variables in JSON files. For that, we'll have developer environment, so we export that file, and the globals file with variables that we want to share between requests or that are not specific to the environment. Then we use the Newman tool to run Postman tests on the command line. We tell Newman the collection, the variable files, the CSV file, and we use a reporter for layout. This is what the command looks like. I've added line breaks here so we can read it easier. To run AI test Postman collection, we need -E for environment file, -D for the CSV file, -G for globals, and the command line reporter, this one increases the output width to 220. When running this in Newman, we're looking to these test results that the expected document file name is in the results, but not necessarily first, as there may be more relevant document added after the test was written. But the expected page number is first in the results because it shows the best answer for that document. And that expected document priorities match. For this run, as I said, we're not comparing the relevance score, we just collected the values to add to our tests later. This is the example output. This has been sanitized and trimmed for this presentation. So it's showing the first 3 documents returned for each query. It shows the file name and the sources returned. We can see we're getting an array of page numbers as a page range, and we can see the relevance score and the priority, and we're logging the matched documents. A summary of these tests will show at the end, and we'll have a look at 2 of those tests in a sec. So this test number 5, this one's a pass. So we have the query and we have a reason note. The expected file name matched. The expected page 6 was included. The expected priority score 14 also matched. And we got a relevance score for this document, which was 96.74%. So we see a green tick at the bottom left to show that these test results were passed. In test number 8, though, the red text displayed a failure. The reason note and the test failures message are logged to the console for review. This test failed because even though the answer was correct, it was too specific. There was a better answer earlier in the document which should have been listed first. The final results in Newman are summarised in a table. It lists iterations, requests, test scripts, pre-request scripts, and assertions and statistics. In this sample of 8 tests, it took under 40 seconds to run with an average response time of 4.1 seconds. So to recap, we recorded a session using Postman Interceptor. We created a Postman collection and analysed the JSON response. We prepared a test suite and exported it to CSV and added environment and global variables and test scripts in Postman. Then we saw the output of these tests running in Newman. So what's next? What else could we add? Some optional enhancements could include testing more results, like an acceptable range for relevance score or chapter titles, or maybe negated tests, ones that should not appear in the results. If these responses were to include HTML, we could use Cheerio. That's a lightweight jQuery-like library for parsing and manipulating HTML and XML. In terms of output, we could also use HTML reporters for a more graphical way to display our results. We can also add our tests to Postman monitors to run regularly, or CI/CD, or schedule in cron even to run whenever we want. If we want to, we can also control the test flow using pre-request scripts. In this example, we used a pre-request script to check the iteration number and then skip the GET request as it's not needed once we're on the AI chat page. If you're interested in Postman, it has a free account for up to 3 users. That's limited to 25 collection runs inside Postman a month, but unlimited Newman runs, so that's what we've been using. It works for us. That's it. Thank you for coming to my session. Appreciate it. Any questions? Okay.
How was the AI tweaked to, like, going back to that fail test where it gave too specific? How was the AI tweaked to not do that and give the list?
Yeah, that's a good question. So the question is, how is the AI tweaked to handle more generic questions or specific questions, to know which is which? So the specific questions, in that case, it's in the building code, and it's referring to, it was showing us an answer for Queensland. So our users are subscribers of our system, so we would know if a user is in New South Wales, and we would need to pass that through to the AI as a prompt engineering to say, okay, this user, this question also needs to specify this is a builder in New South Wales. And then that question would be able to use that more generic answer, which is specific to New South Wales. Thanks for your question. Yep.
I'm wondering who kind of comes up with the test cases, like, because obviously you build it that are going to watch, like, where should these documents, how do you deal with failures?
Yep, so the question is, how do we know which questions work with documents, right? So which are real-world questions. We do have subject matter experts that we can use, but we're not, the people writing these tests aren't developers. We're on the customer side. So we're writing it from our organisation, from Master Builders, and so we're looking in documents for answers to questions, and then we're phrasing questions knowing where we're going to go. We only need the AI to be able to say that document is correct. As I said, it may not be the first answer, may not be the best answer. There may be alternate to correct answers, so the AI should show 2 documents. So it's a part of the development that's ongoing. The more and more expert users that we can get and more feedback we get for questions, we just add them to the test suite. So we have ones like multiple questions on the same document. And we also have questions where we have know the answer is not in that document, and we write a negated test to make sure that does not show in the results. So there's a lot of flexibility there, and I think we're currently at 72 tests. So any other questions? Oh, yep.
So maybe I missed. So in the Postman, you have a test to evaluate the answer to relevance, right? And that part is from Postman.
No, I have the JavaScript. I can show you how we would test the relevance score. Sorry, the question was is how do we test the relevance score. In this case, I just wrote JavaScript to check it's between plus or minus 10% of the expected relevance score. Because if it had an answer and it was 90% relevance score, and the next time I ran the test, it was only 50%, I would want to look into that. So that, as I said before, it helps us understand the content of our library because it's always changing. There's always new versions and new documents coming in all the time. So yeah, it's something that we have to keep up on. And that's why this is useful, because we can run this ongoing on production whenever we need to. So we run it in testing and dev environments, but also on prod. Yes?
Sorry, I may have missed
The priority score. The priority score is a number that we rank our documents in importance in our library. So it's part of our library cataloguing. So our library is a subscription service, but there are documents that are available freely to anyone. And so they would have a higher priority score, so the users would be able to access the free information easily before that we take them into the subscription, the paid information. And also there's documents that we publish ourselves, so they have higher priority scores as well. So it's our way of indicating also to Solar in our search engine to say which documents we want to display first in our results. Yep. Yeah, because we're a member organisation, so we're not about the profit here. We're about providing Australian standards in the most efficient and effective way to users because we're Australian-wide as well. This project is Australian-wide. So yeah, we want people to use standards and building codes. We want people to refer to them, and that's not what's happening in our industry, and that's why we're getting so many building defects. So when we write best practice guides on, say, waterproofing, we want everyone to use them. We want that to be, the starting point of that work. Cool. Thank you very much, everyone. Appreciate it.